Yeah. Okay. So my goal tonight is not to describe all of serverless architecture, because serverless architecture is, in many ways, a marketing phrase. So we want to be careful not to talk about what really talk about something that is real, and not get hung up in the literature and what this person says or what that person says. It has a lot of definitions right now, and it's just one of those things that people are jumping on because they're afraid to not jump on it. They'll be left behind, so everybody's calling their product this serverless thing. I'm going to break it down into two main categories of things that are being called serverless that I think are reasonably called serverless. Reasonable to call them serverless. The main idea behind serverless is that we're quickly moving toward a world where spinning up even VMs to run containers, or even spinning up VMs to, on your own, is becoming an expensive proposition. You spin up VMs, you run some infrastructural code on it, or you run your own code on it, or whatever. That's a thing where you have to have some expertise. One of the big problems with that is that you're paying for stuff while it's not being used. I mean, if you spin up a server that gets hit for real 100 times an hour, well, that's a lot of time you're paying for that you're not utilizing that, right? So the idea behind serverless architecture to me is moving towards better utilization of the resources. So the two categories that I want to talk about tonight, and I'll talk about one more than the other because it's kind of the really hot topic, and that's the ephemeral computing. The idea behind ephemeral computing is that you don't provision servers, you don't provision anything, you just put your code somewhere, and then every time you need to run your code, some event causes your code to run, and it does some work, and then it goes away again. So that's the idea of an ephemeral computing platform. And the prime example of that, the one that's making all the buzz right now, is Amazon Lambda. AWS Lambda is an example of that ephemeral computing, or some people are calling it FaaS, for function as a service. Okay, that's the you'll see that buzz around. The other kind of serverless architecture is the idea that many applications today, especially mobile apps, are really just coordinating a bunch of other people's value-added services. So you might need a translation service, you might need an accounting service, you might need a single sign-on service, you might need, all these things are now available through APIs, so that your engineering effort is actually less about writing value-added, computing server functions or computing algorithms, but more about just effectively combining other people's stuff to make a unique application. So it's happening especially happening in mobile. People. You see it where people just offer a game service that knows how to play backgammon, but there's no graphical assets, there's nothing. It just knows how the game of backgammon works. And then companies who are building mobile applications just go out and build their front ends with all the graphics and all the things they want to play backgammon, and then they go hire somebody else to do some other service that's about people meeting up in a lobby of some kind to play, right? So by combining these services, they end up with a value-added app. Then they sell advertising, which is another service they buy, is advertising feeds, and they end up making an application that maybe they can make money with. So that's two broad categories of what's being called serverless right now. There are others. There's a company called Parse, which falls along the lines of FaaS, but not quite like that. It's a little bit different model. I don't want to get too in the weeds on different models because they're still forming, but the bottom line is, a way to implement applications now is perfectly reasonable to design an application for which you don't provision any virtual machines or any physical machines to do it. So, one question is, why do it? So the big one everybody's promoting right now, especially with this ephemeral computing, is the idea of cost savings. So if I have to run a server 24 hours a day and pay by the hour, when it's only getting hit 100 times an hour, that's costing me a lot of money that I probably shouldn't have to pay if I was able to just run my code on some server that had some capacity. So I actually did this on a calculator today. So it's kind of back of the envelope. It's not, it doesn't consider everything, but the scale of it tells you, the scale of it is what the story is here. So an Amazon Lambda function costs whatever number of zeros, $2 per request. So it's actually $1 per, I think, and I just said it wrong. I think it's $2 per million requests. That's what I think it is. So, and then let's say you settle on some, and then they also charge you for compute time. And compute time on Amazon it's a measure that they made up called gigabyte seconds. So they provision, you set up your functions to run at some level that's measured in gigabytes, and that's actually the amount of RAM you get, or megabytes. That's the amount of RAM you get. It's gigabytes, whatever. But that also determines how fast it runs. I mean, how many, what the power of your CPU is. So, but let's say I don't know why this is doing this. Thank you. Okay, so, but let's say you settle on the 256 megabyte runtime level, right? Which I think is fairly small, but oh, come on, this is not really happening, right?
Put it under the bed.
It's staying on top is the problem. So if you did a 256 megabyte allocation, your compute time costs are that per 100 milliseconds of runtime. So let's say your average request response is 200 milliseconds. We multiply that times 2. We add it to this point, bunches of zeros 2. We end up with this is your cost on average per request. So if you compare that to, let's say, getting like the second smallest instance type at Amazon, which would cost you only 1.3 cents per second, you think that's very small. 1.3 cents per hour, which you think is very small, but that 1.3 cents per hour is the same cost as 12,750 requests against your server and a Lambda function, with these calculations, meaning that you would have to break even, to make those two even from a cost perspective, you would have to be having 3.5 requests per second against your server nonstop 24 hours a day to make it worth it to pay that price for that server. So these aren't numbers that you would ever use because you'd have your own things, but I'm just trying to show you the scale of what we're talking about and why people point to it as a cost saving. Okay. The other thing is the nearly automatic scaling. So when you think about VMs, one of the things that we do when we push things out is we make things into scaling groups so that we know that when we need more capacity, we add more servers. They spin up exactly the same way as all the other servers. Load balancer takes care of going between them. But it's still something you have to build. It's also something you have to think about. What criteria do I have that cause me to spin up a server? What criteria do I have that cause me to bring down a server? If we're all just running these ephemeral functions on a big wide variety of somebody else's servers, we get that scalability with almost for free. Now I say nearly because most of these companies that are going to buy this from, they have limits when you start up. So Amazon may tell you, oh well, you're limited to 1,000 requests in an hour or something like that. But that's something that they will raise when you request it. So you do have to think about scaling in the sense that you will be throttled by your provider, but as long as you're paying your bill, your provider will continue to raise whatever your limits. So you're effectively getting scaling without ever having to think about bringing up a server, bringing down a server, load balancers, all things you have to think about when you're doing that. Another advantage that people quote, the leverage of the expertise that many people, is the expertise. Oh yeah, I'm sorry. So now we're back. That was the ephemeral one. So I'm sorry, I still in the ephemeral thing. So now talking about the assembly side. The assembly side gives you the advantage of the assembly kind of application is you can leverage people's knowledge of domains that aren't in your group. So there are people that are experts in accounting. There are people that are experts in single sign-on. There's people that are experts in building a back-end game. There's people that are experts in advertising. You don't have to have those expertises on your team to build out applications that fully utilize those domains. And that's the sort of app assembly thing. And then also you don't have to have, you have to have less sort of ops experience. You don't have to have none, but you don't need as much sort of operational experience on your team to get the job done. So let's talk about a couple of design, and most of this is leading up towards I'm going to show you an example. So I'm just trying to get the ideas going so we're all in the same understanding of what we're talking about before we get into an actual piece of code.
You can talk about the flip side where it's more useful to not use serverless architecture for Lambda.
Yep, we got this whole section here coming up.
Save it till the end, Joe.
No, you ask questions now. You want the drawbacks now? When you're designing for ephemeral applications, I just came up with some things that came up. So I did a serverless, ephemerally computed application over the last week and a half or so. And it was, I learned some things. And some of the things I learned about design that statelessness is the key. Your code is, even though you might have some state that stays around between runs of your function, you can't count on it. So some of the, like for instance, Lambda will actually keep your code in memory and keep it, but it'll freeze it from a CPU standpoint and then bring it back to life when it's used, so that you're not always paying the startup cost. But that can go away at any time. So they don't publish any rules about that. So they are free to dispose of your code at any time, meaning that you're always going to end up paying the startup cost at some point. You have to think of statelessness. You can't rely on state in your function, in your code. Nowhere can you store state that you can count on. Any state you keep is strictly for maybe some performance reasons you might have, but you have to be able to build it on demand. The other part is startup time is important, and this killed me on my application. So I chose the Java option for Amazon AWS Lambda. One interesting, for those of you who know Java, one thing that happens in Java is Java compiles down to really small class files. Like you get really, really compact stuff until you use somebody else's library. The second you use somebody's library that isn't designed the way you design code, your application deliverable, the artifact, blows up massively. So just by including one Amazon SDK function in my code went from 100 kilobytes in its total deliverable package to 6.5 megabytes. And that was just by including one feature. Ultimately, I think it became about 8 megabytes because I had 2 or 3 features I had to put in there. So my payload is now 8 megabytes. My code, you'll see my code is very small. And so it's unfortunate. But here's the problem with that, is that a cold load of that 6 or 8 megabytes can be like 4 to 6 seconds. And you're paying for those 4 to 6 seconds in 2 ways. You're paying for the 4 to 6 seconds because you're getting charged by the millisecond to run it. Second thing you're getting charged for is you now have a 6-second latency on something that you're expecting a millisecond latency on. So when you're designing your code, I think that's one of the unsolved problems so far, is how to make the leanest possible package for these deliverable artifacts that you can when you're delivering your code. Because what's happening in the case of Lambda is it's loading it from a transactional store, like probably S3, I'm guessing. I probably is S3 if I recall some document I read before. But it's loading it from S3, which means a transactional download of your code from an HTTP server, and then it runs it and loads it and fires up and does all the class loading. So, people are talking about Java startup times are greater than 10 seconds in Lambda. My typical response is 4 to 6 seconds on that 6-ish to 8-ish megabyte file. But my functions aren't complicated. So, I mean, if you get stuff that's more complicated, you're definitely going to be paying that price. Yeah?
Just for like a hello world Lambda function, have you tested to see what the startup time is that?
It's like nothing.
Okay,
yeah. So
it's not just JVM startup time. It's
not
It's definitely download time.
Yes, the JVM is all in place. It starts up really fast.
Okay.
If I do a hello world, I can get under 100 milliseconds for every single call on like their smallest box, on the smallest provisioned amount that I can get.
What functionality did you use on the Amazon stuff? Because that seems a bit ironic for Lambda.
Well, and I was thinking of that because this code, by the way, that I wrote was for entering an Amazon sponsored contest, and so the fact that using their code, using their SDKs is what causes this to be a problem is something that's has to be brought up. I'm not bringing it up in my description in my entry because I don't want to be somebody just go, I'm not going to put that one on there because he's criticizing our code. But that would be the next step, right? Is to start thinking about how those things are.
So do you think some competitors? Because there's the 2 SDKs. There's the Java one, which is C++. Do you think a lot of them are using the C++ one? If that's clear?
Well, there is no C++ thing for Lambda. There's only Python, Java, and Node. So most people are doing Node because Node was the first one that they offered. And it's also probably the lowest order cost. But anyway, those are things to think about as you're designing these things. Think about your startup time.
I have a question. So if your code calls something else, and that takes a very long time to return a result to you, you end up paying the time for the overall transaction.
You do.
Even if you call Amazon itself, right?
You do. So what you need to do is think about how, so when I wrote here, think of your code as cooperating systems of event handlers. That's a better way to do it. So if you can design your code such that you make a request and then drop out,
programming then.
drop out, yeah, and then expect something else to respond to the result, That's the best design, especially if you have long-lived dependencies. So you want to issue a request, handle the result in two separate things if you can.
That's for the Node programmers. They're already used to program that way. Whereas a lot of Java programmers, it's alien to them.
Sure, but even in Node, they're not going to be able to do that here because they don't have a way of dropping out and then doing that continuation style.
Right.
If they have to start up again, so they have the same exact problem. So, but you're right. Their mindset is already there in terms of handling things asynchronously. Yeah. And then, or maybe just collection of transformations. The other thing that these kinds of functions are really good for is if you've got a big stream of stuff coming in, and you can fire up this function, handles this gigantic load of stuff that just came in, gets done and drops out, and transforms to something else, maybe another set of stream of events going somewhere else. That's that's right for this kind of design, right? Because those kinds of processes are often just sitting there waiting for stuff to happen. They're not happening all the time, but something big happens, a big event happens, there are a whole bunch of little events will come in, process them, get rid of them, go to sleep, wait for the next batch to come in.
So I actually have a use case for that in that case, because we have this thing where we process product catalogs. So it's a big, gigantic catalog file.
Sure.
And then there's nothing for a long time, right? So how fast is it out to scale then? Because when it's processing, you want full speed.
Right.
And then you want nothing
so
again.
you're running on full EC2 instances to extremely fast hardware if you want. So you can be running on and they have lists. If you pick the 1.5 gigabyte level, they'll tell you exactly what number of CPUs you have and what your allotted CPU units are. They have a mapping for that in Lambda, so they'll tell you. But yeah, you're getting fairly beefy equipment if you choose those levels.
But the biggest problem with Amazon Cloud is that the biggest constrained resource is network I/O within their cloud. That's always the one you run into, and that's always one that we have to pay extra to get. CPU, I barely see anything go over a few,
It depends on the nature of your app. So I wrote an app based on hundreds of EC2 servers that was doing transcodings on media. Very CPU bound. Okay. So in that case, yeah, you're not, so it just depends on your application. But both network applications today are completely I/O bound. I mean, they're all about coordinating outside services.
Yeah.
Right. So your CPU sits there idle for long periods of time. In that case, you're right that the network bandwidth is a problem. But the way Amazon ties their EC2 stuff is that in order to get the better network performance, you have to buy the higher end stuff.
So it's still the same way then? Okay.
It is. It's tied to the same thing. So they do it. I don't think there's anything nefarious about it. I think that they do it because they don't want to have to they don't want you to have to make 37 choices when you provision a machine. They want you. They try to simplify. So I'm buying this level. I'm buying this level.
Why even define a machine at all then? Why not just have them figure out how to run it based on its behavior?
That's what this does. So I imagine you're being throttled. Imagine you're all on the same hardware and you're being throttled. But I have no idea. That's something to experiment with. I don't know.
But you have to specify the type you want your Lambda functions to run on.
No, all you do is specify the memory size. And then your CPU throttling is based on that memory size.
And what about the I/O?
I/O is not specified at all.
Okay, so you just scale with more.
That's my assumption.
Okay.
I don't know. And this is not a pitch for Amazon Lambda. The only reason I know it is because I just did an application in Amazon Lambda. There are some alternatives that are almost this identical. Firebase is one. But there aren't many that are exactly identical. It's pretty low level when you're on Lambda, so you've got really low level. That's the way Amazon does everything, pretty low level. You have to build value out on top of it. All right. For designing service coordinated type apps, this is something I have less experience in, but my app did a little bit of it, so I will tell you some of the things I learned. The service offerings will dictate your design. So what I found is the compromise is sometimes, because of the way things are priced especially, the compromise is sometimes that you might find 3 services that together would be perfect for your app, right? And you want to go buy all 3 services, but each of those services costs $15 a month per user. The problem with the pricing models for most things right now is that they're like this per user per month kind of level, and not at a per transaction level. So what you have to do in those cases is just pick the one vendor that doesn't have quite as good, but you can make the application work with their thing, but then you're only paying $15 a month per user. Those are the kinds of design decisions you have to make now. I'm expecting that eventually the pressure will be on these companies to offer per transaction rates on everything that you do. So like, for instance, my application uses Google Translate API. Google Translate API is per transaction. I don't pay any monthly fees on it. I pay per character translated. I think that more and more of these services are going to start offering at that level because it's the only economic model that makes sense when you're trying to combine 10 different vendors into one application. So I think that'll get better. It's just not great right now. And then if you have a browser-based application, I think mobile space is better than this, is better than the web, than the browser space right now. But even if they're kind of identical programming models, the mobile space, you have a lot of built-in identity functionality in the platform. So as you're running your mobile backend, or if you're talking these backends, a lot of the identity passing around, the single sign-on, all that kind of stuff is all being handled for you by the mobile platform. In the web platform, it's still not quite compatible. So you typically will end up, if you're doing something for a browser-based application, you might end up having to have at least one ephemeral or server-based application that does some of that coordination between credentials and secrets and things like that. But other than that, you can actually go out and use your browser to coordinate all these applications.
So do they provide any form of session, or do you have to build that yourself?
No session. So these are totally stateless.
Okay, so that means you have to have your own sessions, your own app tokens that the client then would have to send through every call and everything.
Yeah, or do a sessionless design. I mean, that's the other way to do it, is that
Risk
like a shared nothing
right?
design.
If you want to make money, right?
Sure.
Because you need to know who is calling you so you know how to charge, right?
And that you deal with by having, you can have persistence backends. Like, for instance, my application has a DynamoDB backend. So it does keep track of when somebody subscribes to a channel, it makes that recording that somebody subscribed to a channel.
But you don't want to hit S3 every time, because if you hit S3 every time, it's going to increase your transaction time and you end up paying more, right?
But something like DynamoDB, where you have very fast transactional key store or something like that, works fine. But yeah, you may have, and a lot of times what I see this moving towards is event streams. So as you are working, your front end, all it does is it fires off an event into a queue, and that might be like a Kafka or a Kinesis backend or something that's just a big event stream, and then you have things that fire up when they need to process events. You could build an application that had very low ratio of dark time to live time. I mean, I think it's an interesting way to look at applications and start designing applications. So I'm excited about this just because it's another tool in the toolbox. It's certainly not going to fit every scenario. So a couple other things you need to worry about: leveraging a DevOps mindset. So I'm hoping that everybody does this. And if you're already doing POS like with Heroku, you're probably already doing a lot of this. But everything you need to do needs to be repeatable. And I say this even with like an IaaS like EC2. If you're poking around in a console to set up your infrastructure, you're doing it wrong. You cannot possibly scale that, because the amount of knowledge you have to have as your application grows on what to poke at to bring things up and down and manage things gets greater and greater and greater. My first cloud application scaled, like I said, to hundreds of servers with all kinds of different applications, and this was several years ago. And we started out with the poking at the console type of mindset of spinning things up, and so it became this thing. We have to add some servers. Okay, we need to go through every region, go pull up all the console. It was a nightmare. So when we switched around to completely code-driven operations, it changed our lives drastically. And I think that's the mindset you have to have going into this. So if you're already doing that, you're already ready for this. But if you're not doing that now, before you approach this, you should do that, because now you're talking about managing, dozens of little pieces of code that have to be managed and put into place as you change them, and where do they go and how do they get provisioned and all that. So try to have that sort of operations as code mindset going into this. And finally, we'll get to Joe's downer question. The drawbacks of this. I'm so depressed now. So some of the drawbacks are, one of the big drawbacks I think is that you have to care about bloated library code. You have to care about other people's code now, way more than you used to have to. If you run a Java container in a server, I don't care about bloated library code, because I only start it up when I deploy, right? And it starts up, so it takes 40 seconds to start up. I don't care. I got 5 servers behind load balancers, takes 40 seconds, and then it runs for 3 days, and that's great. But here, you're talking, you don't want to have something that takes 40 seconds or 60 seconds to start up just to run 300 milliseconds of actual computation. So you start now to really care, and as I told you, the second I added one SDK from Amazon SDK, I blew up my application a factor of 60, right? Doing that, something you don't want to do. So pressure will be on library vendors to make leaner code, I hope. But you need to really care about that more than you normally have to care about that. You also have to worry about your development language and stack kind of requirement or stack options. For instance, AWS Lambda, as I said, offers Node.js, Java, and Python. That's it. You don't get any other choices right now. Now, technically, there are workarounds. You could package and execute a Linux executable with your Python code and have your Python code run it, right? That kind of thing. But that's not an architecture I would, suggest, because I think it runs counter to what we're trying to accomplish in these cases.
There's Amazon Kubernetes for Haskell.
Yeah, there you go. But that's just for operating Lambda, not for actually running Lambda. Yeah, that would be for actually provisioning.
Can you run just straight up binaries, like pass it up?
Well, that's what I'm saying. You could, but you have to then package it with your, let's say, Python code, and then get your Python code to find it, and run it. And you have to target it at the exact Linux that you're running. Make sure it's running the right kernel, and it's not designed to be that way. What's that?
Could use Python then, Java for Python.
Yeah, you can do a lot of things like that. It's just not. It's out of the spirit of it, and it just means your code becomes more and more complex because you having to worry about now the underlying operating system. This is the whole idea of this is you're not worrying about the operating system anymore. You're just running your code. But
did you ever try the Node part of it?
I have not done a Node. No, I did a Node one about a year ago to try Lambda for the first time, but I just ran through somebody else's example. It works great. That was the first one they offered. So I'm just not a JavaScript programmer, so I chose Java.
Have you looked into TypeScript?
I've seen TypeScript, I haven't run it.
Yeah, because that's a typically way easier path.
Sure.
You have the OP concepts that you're used to.
Mm-hmm.
You still have it and types.
Right.
I have a question for you.
Mm-hmm.
So for most systems, it seems to me that for the systems that I manage, right, it's fairly big. Not everything could run as a Lambda functions, but I can see how some aspects of it would do really well as Lambda functions because of its behavior. It's typically here's a lot of data, needs to get processed, and after that, it does absolutely nothing, right? But when it's processing, I really want the maximum amount of processing available, right? So it seems like there's probably going to be a lot of hybrid solutions where you use Lambda for certain things.
Yeah, and I think that's where you're going to see it. Like you're going to see it as, why do I need to have a high-end server sitting here dark most of the time? Right. So.
And the problem with that is that the servers we use for that, they're big servers because when they need to process, they need to process a lot of data.
Mm-hmm. Absolutely. Another concern, another drawback with these serverless architectures, you are increasing the surface you have to defend from a security standpoint. So if you are coordinating a whole bunch of other people's services, or you're running a bunch of individual Lambda functions, each of those has to be secured. In Lambda, there is the option to put your endpoints behind VPCs, but that doesn't solve the third-party operations. Just note that security is a different concern in this kind of architecture than it is when you're running all your servers in a virtual network, with you controlling all the entry points.
Did I understand it correctly that they still run within your part of the cloud, or do they run outside?
You can run them in a VPC, meaning that the only endpoints are available only in your VPC.
Okay.
But the servers themselves are there. They're not. You haven't provisioned them. They provision them.
Right.
In whatever they need to get it done. And then some of your I heard some claims that vendor lock-in is a disadvantage. I hear this all the time. I'm not a big. I never worry that much about vendor lock-in. I know it's a concern, but in my experience, if you're writing Java code, you're going to be able to move it to other places to run Java code. For instance, Python, I imagine, is the same. Node the same. The lock-in is largely around, and it doesn't matter whether you're IaaS, PaaS, any of these types of services. The lock-in is around the management infrastructure in these kinds of services. So they all have their own way of provisioning. They all have their own way of, their own APIs for getting stuff provisioned and getting stuff managed. That's where the vendor lock-in, and it doesn't matter whether you're doing Lambda functions or spinning up VMs. It's their proprietary API to spin those up. So the lock-in, I don't think it's any different lock-in problem than any of the lock-in problems we already have, right? So my suggestion around solving the lock-in problem is just to always is to write code to do everything and make the lock-in problem just a software development problem. Some things that are still being worked out, things like secret delivery, how we get because there's still the turtles all the way down problem where at the bottom, somewhere, somebody's got to finally say, I got a secret and I know it and I store it. And that doesn't go away because of this. As a matter of fact, in some ways it makes it harder because you don't control the servers that these are going to be run on. So you have really no secret store you can go to other than some well-known secret store. And that's, again, the same problem that you have in any other environment. Fine-grained throttling. This is actually an interesting, I didn't even think about this, and I was reading up. So if I go to, so this is about like killing yourself with your own denial of service. So you have your own app, somebody finds a way to use it that abuses your service, right? So you're getting tons of requests coming in. You don't have a way right now with the way these cloud platforms work, or the way these ephemeral platforms work, to say, I want this one throttled this way, and I want this other one throttled the other way, and I want this other one throttled the other way. You basically get limits for your whole account. So if your whole account says you need to like bump it, I need to be able to do 1 million transactions or 1 million transactions a month or whatever. Well, that 1 million transactions you meant for this service, but it gets used by some other service that's being abused by one of your users who figures out a loophole. Those are the kinds of things they probably need to start figuring out, helping us. One of the things that helps, the service I'm using in this application I'm about to show you is a service called API Gateway, and that does have per resource throttling available.
So I have a question about the limit. So is the limit on account level though, or where is that level at?
Right now the limit is account level.
I see. So you would have to have 2 accounts to work around it.
Yeah. And Amazon gives you, if you're trying to pay for them all with one, you have a limit of like 25 accounts. So that's not really meant to be the solution to that, right?
Right.
Yeah. So, but I will show you a solution, and part of the stuff that I did here for this application, and that is to put it behind a gateway that does have fine-grained throttling, and that's what we're doing here. So I'm about to show you an application. We're going to fire up some actual code. This is just pretty simple Java code. All right, so this is a bot I wrote. Slack. Are you familiar with Slack? Ever use Slack? Okay. So I wrote this little Slack app. No, look, Slack is offline. It keeps going offline all day today.
It's been really bad.
It's because your wireless isn't connecting. That's that message you kept.
Yeah, you kept canceling it and putting it to the side and saying go away, but he's trying to help you.
Was it trying to help me?
Yeah, there you go.
Oh, this thing here?
Yeah.
You think this is trying to be a helpful thing? I don't know.
Look at that little pulsating.
Continue?
lock.
But as soon as I do this, it says, no, it's no good. Nope.
Yeah, that's been happening.
That's your local password.
Don't have a local password.
Your certificate trust settings password.
Yeah, there's 2 different. Is it?
Did you recently change it?
It's the same one. So try all like your passwords you've had in the past X amount of days.
That's right. It's like before it locks you out.
Sorry, people listening to this recording.
Yeah.
Oh.
My local password is from like when I first got here.
I can't type it.
Since
Yeah.
it's not the LDAP.
Nope. I went back to all my passwords since the beginning of time. So, but you think that's why I'm getting no Slack?
Yeah, because you don't get anything.
No, I've been on the internet. That's how I got these things. So.
If that was before the certificate started popping up.
Oh, okay. Well, should I try losing the VPN? Should I go on the guest network? That might work. They know the guest password.
Or do you want one of those cables? Yeah, just connect and.
I don't have a cable connector.
Here, you can connect to StuFone 6 Plus with my top secret password. Personal hotspot.
It's been the merge. Missed my email.
Yep, no internet connection. That's awesome.
All right. If you connect to StuFone 6 Plus, the wireless network, and use ABC123 ABC.
StuFone. Do I have to type it in? It's not broadcasting it.
Should show up.
If you turn Wi-Fi off and on again, see if you go. No, it's looking. You
Oh,
just
sorry.
activate that code. It doesn't check constantly.
Yeah.
But you can trigger by turn off and on.
All right, let's try it. There it is, StuFone 6 Plus.
ABC123 ABC.
ABC 1, 2, 3, ABC. Look at that. Show the password. Okay.
Now you're cooking. Now let's try try some man-in-the-middle attacks.
All right, let's get Slack fired up again. Looks like it is. All right, so this little application is a little translator application that as you type stuff in, like what's the weather today? It goes out and it translates it for you as long as it hasn't. So this is that 6-second startup thing I was telling you about before. So it's been a while since I've used it. So what you're getting is that you're getting the cold startup problem right now. Now if I do it again, it's almost instantaneous. Well, yeah, it's almost instantaneous, but it's over that network, so I'm not sure how fast that is. But anyway, so what we're getting is a translation. If we do it from this other client here, where I've actually authenticated to it, I can say and it'll actually modify my messages in languages, and it supports a bunch of languages. You can set it to translate in all of these different languages. No, not again. That's a second function that has to start up separately. Now it will work. There you go. So there's all the languages. I can show the languages that are being in this channel, and that'll show me what's being translated in this channel. I can change, add, remove languages and whatnot. So that was my bot that I wrote, and I did it strictly in Lambda functions, and I'll show you those now. So this has 3 parts. The first part is, they're all here in this little thing called app, and this is Java code. So there's 3 handlers. There is a command handler that handles those things where I type /command. There is an event handler, which is always listening to all the messages handled in the channels that it's belonging to. And then there's an OAuth handler, which handles the initial handshake between the application and your Slack team. Mm-hmm.
It would be helpful to understand from a system level what is calling what in what sequence here.
I will tell you that. So let's tell you about handlers first. So the way that this works is, if I'm in Slack and I type a /command, I say add Chinese, right? Now I'm translating in Chinese. What's happening there is Slack is making a call to an API that I put out there in the world, and using an authorization token that we have negotiated. And my Lambda function spins up, handles the request, then goes away. Okay, that's for that. Now for everything else we're doing, hello world, it's going to be translated. What happens here is another handler so Slack is now sending events that my application is subscribed to. So again, that was a handshake at the beginning. I said I want to subscribe to X, Y, and Z events. It's going to send, in this case, it's just message events. It's going to send every message event to my app at an endpoint, and that endpoint's going to spin up for every message and then fall down for every message. So that's how that's working. So I'm handling.
Sorry, how do you keep state of all the languages that you currently set up?
I will show you.
State.
Yeah, it's interesting.
So this is not stateless. This is serverless, but it does have a persistence backend, and I'll show you that in a second. So talking about the command handler, this handles the /commands. It's all done in this little thing here. Now, the cool thing about Lambda, the Java binding to Lambda is you can it'll do serialization to objects if you want, but the simplest thing I found was not to worry about that and just pass maps back and forth. So it'll take everything that comes in that looks like JSON, and it will convert it into a map, or a map of strings, or a map of maps, whatever I decide I want it to be. It's pretty forgiving in what you ask for. And so this is my command handler. It just goes through and it checks what you're asking for, makes some decisions, and then responds. In the case where it needs some persistence, there are some persistence here, like the database value retriever, that go and reach out to Amazon DynamoDB and use that strictly as a key value store for keeping track of everything. So it was really just a matter of designing the keys. And and it's a simple key value store that's really fast and attached locally. So that's really fast. Same thing with the event handler, same kind of thing. Just comes in on a map, and we process it. We see what happens. We do all the translations. We go out and we find all the keys we need to talk to Google Translate. We translate all the languages, and then we respond with that. And we do that by posting messages back into Slack in this case. So the command handler is different. The command handler takes in a request and passes back the message to print. That's how that thing works. The event handler actually is just expecting, it throws away the response and expects you to then operate the web API or the Slack API to do all the responses. So in some cases, I'm modifying the message and putting all the translations in place. In the cases where the user hasn't yet authorized me to do that, then the bot just posts and says, Mayoke said this, Mayoke said that, Mayoke said that, right? There is so then finally there's the auth handler, which has done pretty much the same kind of thing. This handles the OAuth flow, gets things in as a map, runs through, invokes this is what's called the authorization grant flow. It's one of the profiles in OAuth 2, and it just basically runs that flow as a client. Now, to wire this all up though, let's go to the Amazon console and take a look at how this looks in Amazon. So I don't actually manually put these in place, but I will show you. Let me log in. Let me go to my account from here. Yep, I'm logged in. So we can go over to make sure I'm logged in the right account. Yep, Jam Administrator. Let's go over to Lambda. So you can see I have a few Lambda functions here. This is an old one for an old bot I was writing that I had to change directions on. By the way, I started out writing one bot, then found out somebody had completely solved the problem perfectly well, and so I had to write a different bot. So these are the three handlers we talked about. So you go in here and you can take a look at again, I didn't poke these in through this console, but I can certainly look at them. These are all created by code. Let's look at the one that handles commands, and you basically provide a code by giving it a zip or a jar file. Here's the configuration I was talking about with selecting a level. So these are selected at the 1 GB level. I did that temporarily just to cut down the cold startup time. But you can go anywhere from 128 as the smallest all the way up to 1536, 1.5 gigs. Those again, they also change your CPU allotment based on your memory allotment. You also set a timeout. So you can say if this thing doesn't respond within, now I used to have this thing down to like 3 seconds, which is perfect except for the cold start. If this thing doesn't respond within 30 seconds, it'll just go away anyway. This has no triggers because I'm not doing it. I'm using an API gateway, and monitoring is set up to do logging. This will show, if you want to, you can see the kinds of things that have happened. But what this is all hooked up to is a service called Amazon API Gateway. API Gateway is a pretty cool product in that it lets me set up, to go to that same plane, the command handler, it lets me set up resources, HTTP resources, and the methods on them, and then determine what's going to happen. And all this does is it comes in and it maps things based on various incoming. You can tie it to various header values, arbitrary header values, all kinds of body things. Sends it over to an integration request. Integration request has these things called body mapping templates, which take the incoming code in whatever form it is and use a velocity template to turn it into JSON. So at least for this case. For this case, we need JSON output. So there's a velocity template here that takes the incoming form encoded data, turns it into JSON, and then sends it on to the Lambda function. And then then it reverses. You have reverse map. You can take the response and map it to whatever you want, and then map that out to your final method response. So this is all, again, I don't poke around in the console to do this, but it's just interesting features here. It also has this feature of the idea of a stage. So you can publish your API to multiple resource names. In this case, I have one called Advance, which actually shows up as this URL plus the names of my paths, so that you can have multiple versions. You might have staging versions and production versions and whatnot. Let's go on to, so that's how that works. So this is just sitting there as an API, as a REST API, a REST-ish API that is accepting your commands, passing them on to Lambda, and then passing back the results.
How do you see actual log? logs, like log data?
I can go over to CloudWatch and take a look at my logs over here. Now we can also pipe these logs into something like an Elasticsearch, which they have something like that, which you can use for managing them like a Splunk kind of thing.
Mm-hmm.
But I don't have it to that turned on for here. I just have it turned on to. So here's all the logs for my actual Lambda functions. Looking at the command handler. Here's the last few things that happened in the command handler. It tells me it started up, maybe did some logging, and went back out. I'm not a big proponent of logs, by the way, so I don't.
So how do you do troubleshooting then if your code is not quite doing what you want? Can you simulate it?
Yeah, I mean,
locally on your
I'll
machine,
usually,
or?
that's what I usually use logging for, if I use it at all, is I use to put traces into my code and then just run them. This is all deployable so quickly that you can just get it out there. But we do test-driven here, so for the most part, I do everything test-driven except when I'm running a prototype like this. And so most of the things that need to be tested are already tested, and they don't actually require any of these outside services to work.
I can see that for the logic, right? But
Yeah.
what about when you're doing system integration? Because that's where things go haywire.
Yep.
You're calling something, but is it calling it? Is it receiving it? Is it,
And that turned out to be the biggest sink of time in this project, was learning how all the different parts worked. And that was painstakingly going through tracing and logging and figuring out exactly, because the documentations never tell the whole story.
Right.
So you go in, you just try it, and then you see what it actually does, and then you say, oh, that's what they mean by this, and then you program accordingly, and that's how I did it in this case. But I presume that eventually you end up with a library of these kinds of things that know how to behave in this scenario. And so you stop having to worry about that so much. But let me show you one more thing about this. The other thing about, so let's go back to the code. So aside from the handler things you just saw here, this is the part that I think is the most important thing to take away from this. And this isn't even quite there yet, but at least it's starting to be the right direction. So if you look in this second project, which is called Translate Bot Deploy, this is all Java code having to do with making those things happen in Amazon. So this is actually, in some cases, more code than the actual code itself, this deployment code. So if you look at the things I have here, and if you look at I have a better list if we go over to the GitHub. This is all in GitHub, by the way. You can go look at it. So this is all in GitHub. You can look at the actual code. But I have here listed, if you want to run it yourself, you do have to run these 5 things. And the reason there are 5 things now is because while I'm developing them, I want to be able to spin them up independently and try things out differently. Eventually, then put them all together into one sort of Uber deployment package that would get everything out in the thing. But there's one that deploys the databases. There's one for each command handler, event handler, OAuth handler that deal with spinning up the Lambda functions and spinning up the APIs, the API mappings. And then I have one for deploying the website. The website is just the place where you go to sign up. Although that's not needed so much anymore because now I put the Add to Slack button right here. This is the OAuth flow, by the way. If you start here, this will run you through the whole OAuth thing, and this lets me authenticate to my Slack provider. Tells me all the things that the spot's going to be able to do with my Slack account, and I authorize it. And so this is all being done by that OAuth handler you saw. So there's 3 handlers. This is the one for handling the OAuth flow. And I have this lovely page that really could use some love and care with somebody who actually knows how to design web pages. But this tells you what you would want to do once you add this to your Slack. But that's it. The main thing that I wanted to get across here, though, is that this is a really interesting technology. I don't think it fits every scenario, but I think there are some scenarios where it fits perfectly. And so as you're thinking about your applications and how you might want to architect them, this certainly should be something on your tool belt to think about. And now we can have open discussion or questions or whatever you guys want to do.
So the translator bot's interesting, but
What's that?
It's mostly a toy for the sake of this purpose.
Sure.
If you think of anything else or that other thing you want to do, that's probably more useful, or at least that'd be more interesting or more complex than taking input, doing something with it, sending it back. There's some more complexity.
Right. So that's a talk I'm going to give actually at one of our workshops here. I really think a good user interface nowadays is this idea of chat ops. So the idea is that we have so many applications that fit into our collaborative day, that if we could have these helpers sitting in our chat systems that recognize when we were doing certain things and said, oh, let me help you with that, and then helped you with that, I think that'd be an awesome way to interact with most of our systems, especially as developers. And we deal with so many technical systems that, when you're doing something, you're having a problem, we're solving a problem on Slack and we're back and forth talking about hosts and things like that. I can't log into this host, can't log into this host. Well, some friendly bot said, well, let me file a ticket for you for that and get, recognize that you were doing something. Those are the kinds of applications I think are really would push and really make this natural language processing and all the stuff that's happening in machine learning could be combined with this and would really be interesting and useful user interfaces for the things we do all day long rather than, again, poking at GUIs all the time. So yeah, I'd love to do more complex stuff. The one I was going to write again was the one that would help you schedule meetings.
That one actually seemed like it was easy.
So that if you said, "Hey, Stu and Joe, we need to get together and talk about this before Friday," that this thing would step in and say, "Hey, let me get you a room and let me find when your calendars are good and go out and schedule a meeting for you."
Yeah.
I found somebody who does. They don't do it quite as natural as that, but they do a really good job of that whole scheduling thing behind different calendars. So I aborted it and went with this instead.
Cool.
Anything about the serverless stuff?
That 6-second startup time, I know you said it was because they bumped that high because of the library included. But I didn't catch all the numbers quite, so this is a simple math problem, but that could very quickly make it not a candidate for, maybe categorically not a candidate for.
At least not in Java. See, that's the thing.
Yeah, right.
Right? It might not. It might be Java that's the problem. It might just be that we need to rethink how we compose projects in Java if we want to use Java.
What makes it turn off?
What do you mean? When it exits, when it responds to something.
But you don't pay the 6 seconds again instantly, right?
No.
So it keeps it alive for a while.
It keeps it frozen, yeah.
For how long?
Well, that's not specified. The rule of thumb is that if you don't use it for about 10 minutes, it's likely to go away.
And is that per command?
It's per function.
Per function.
The setup stays active for 10 minutes.
It just basically freezes the CPU and then continues it when you call it again.
There's certain functions that trigger then for Amazon to say, okay, this person responded with this type of function. Maybe it's okay for me to freeze.
So you could,
Okay.
So you could potentially fool the system then by adding a ping parameter that makes it do nothing other than just returning to keep it alive. That you just call frequent enough so you don't pay that price.
Health check.
Yeah.
Right. Health check. There you go. Health check. There you go. Like that.
But it's almost counterintuitive at some point where you just have to pay for that.
No, but it happens a case where you don't have a lot of calls, but you don't want to pay the price.
For the startup, right?
Yeah.
That's not the same.
My expectation is that this all will get way better. For one thing Amazon could do right away is they could take their SDK and make that part of every container right away, right? They own the SDK, they own the containers.
Right.
Why can't that just be on the class path when I start? And I wouldn't have to include it in my jars, right? That kind of thing. I imagine that they'll get better. This is infancy. This has only been around for less than a year. So I think it's getting. I think there's a lot of room for improvement, but I just think it's a really interesting trajectory.
Well, I mean, that same problem is just a more general problem. Like Java doesn't make a good way to deploy your stuff in a modular way.
Right.
If it did, then you've got these item code jars. You can just keep tracking with hashes or whatever.
Yeah.
Your 90% of the stuff you use that's probably on Maven Central is going to be on those boxes.
Right.
That goes away. Maybe you can do some creative class loading tricks. Even in that, I don't know.
Maybe.
I'm just thinking about it. Maybe not.
So. All right. We put this to bed. Hopefully it was useful and informative.
It was very interesting.
All right. Thanks.
So is there a Java tool that will strip out code in the library?
I tried one. Yes, I tried one. That was one of my first things I did. The problem. Well, let me turn off the. Let me turn off this. I don't really know how to do this.
Would you say a Java program that'll do what?